Now see student, next point, phase transition. Now up to this we come to know about phase rule, then applications of phase rule, and last application for the extraction of organic substance. Now somewhat topic is changed here. Now next and last point of this unit is phase transition. As you know, when solid is converted into liquid, there is a phase transition. Then liquid is converted into gas is also phase transition, and there is one more, that is the plasma state is there. Okay. Now this solid when transferred into liquid, it is called as a melting, or liquid after freezing gives a solid, it is called as a freezing. These are the various states, and conversion from solid into liquid is melting, liquid into solid as a freezing, or liquid into gas as a vaporization, or gas condensed to gives liquid, it is a condensation, or solid directly transferred into gas is called as a sublimation, or the gas directly converted into solid is called as a deposition. Okay. Now plasma and gas, plasma to gas is called as a recombination, and gas to plasma is called as a ionization. Now in this way these are the various phase transitions. Now as far as the Clausius-Clapeyron's equation is concerned, there is a equation that is the characteristics of a phase transition between the two different phases of matter. Different phases may be solid liquid, liquid gas, gas plasma, or gas solid any. Now this is dP upon dt is equals to delta HV upon T into VB minus VA. Here this is, if suppose we consider liquid to vapor state, then VB becomes V at a volume of vapor state minus volume at a liquid state. Then this VB becomes VV and VA becomes VL. Now in this way, this is nothing but a Clausius-Clapeyron's equation. Okay. Now for solid vapor it will be VV minus VS, that is solid. Okay, where this delta HS is the molar heat of sublimation of substance. Here this is the molar heat of sublimation of liquid here. Okay, VL is the molar heat of vaporization of liquid, and here molar heat of sublimation of substance. Okay, solid into vapor, that's why sublimation, because you know when solid is converted into directly vapor, it's called as a sublimation. Okay, here liquid into vapor is called as a vaporization. Okay, then next one is solid into liquid, that is called as a melting, that is the fusion. Fuse means when melt, it is called as a solid into liquid. That's why here the same equation is there, only there is a delta HF. What is delta HF? Molar heat of fusion, molar heat of sublimation, molar heat of vaporization. Vaporization means liquid into vapor, then sublimation means solid into directly vapor, then fusion means solid into liquid. Only you have to see this. Okay, now this is about Clausius-Clapeyron's equation. Now last point and very important point so far as our exam is concerned, partial miscibility of liquid. Now you know partially means very small amount. There are number of liquid pairs which are soluble into each other or miscible to each other into very less extent. It's called as a partial solubility. Okay, now as the temperature varies, then there will be change in their solubility. Okay, now see the partial miscible liquids. There are number of liquid pairs which are only partially miscible with each another. Their miscibility varies with the temperature. Okay, now accordingly the three pairs are considered there: phenol water system, triethylamine water system, and last one is nicotine water system. Now see first one, phenol water system. this is phenol and water are partially miscible liquids. Okay, now they are phenol and water, they are partially miscible at ordinary temperature. On shaking they form two layers. Okay, because why they forms two layers? Because they are partially soluble. Okay, as the temperature increases, what happens? Their solubility increases. Now the mutual solubility of phenol and water is one another increases with the rise in temperature. Therefore, at a certain temperature there is a formation of homogeneous one phase solution, that is phenol and water becomes completely miscible. This temperature is called as critical solution temperature. If we plot a graph of percentage of phenol, okay, now this is the graph of percentage of phenol. Here 100% phenol. Okay, here there is at initial state there is a 100% water. What is there? 100% H2O. 100% H2O means 0% phenol. As 5% water, then 95%, sorry, 5% water, then 95% phenol. Okay, here there is 100% means here 0% water. Okay, now this is the homogeneous mixture. Okay, at which there is temperature. Now see this, at this stage 0% water, 100% water, 0% phenol. Okay, 5% phenol, 95% water, means here water axis goes on decrease. In the similar way, along this x-axis percentage of phenol goes increase, and at about 34 means this temperature corresponding to this mixture, the temperature will be 68.1 at this point. This is called as a critical solution temperature, that is the CST of a phenol water system. It is the CST, critical solution temperature, which is a mutual solubility temperature. Okay, now the mutual solubility temperature at which the mixture of a definite composition becomes homogeneous is exist, means at this stage when there is a phenol 34% and 36%, okay, becomes water, means when phenol percentage is 34% and 36% water is there, and you heated this mixture, then it will be observed at 68.1 degrees Celsius they get completely miscible into each other. This is called as a critical solution temperature. In this way, for this second pair, triethylamine and water, now see here there is a second example of a phenol, the partially miscible liquid, that is triethylamine and water system. Now what happens in this triethylamine water system? There are, see, triethylamine water system. Now there are some liquid pairs in which the mutual solubility decreases with increase of the temperature. Now triethylamine water is an example of this type. Are you getting clear? The mutual solubility decreases with increase in the temperature. Okay, that's why what we have to do? We have to do opposite. As the temperature decreases, mutual solubility increases. Okay, and if the temperature increases, the mutual solubility decreases, and this will have a lower critical solution temperature below which the system has only one phase layer. Okay, the lower critical temperature for the triethylamine water system is 18.5 degrees Celsius. How it is? It will be 18.5 degrees Celsius. Now see in the diagram, 18.5 degrees Celsius. Now here this is the temperature. Okay, 18.5 degrees Celsius. This is the triethylamine percentage composition. Okay, now if we plot a graph, again same, here temperature axis, y axis, and here their percentage of composition, then at a temperature, decrease in the temperature, okay, here 18.5 degrees Celsius, they will be completely miscible. Now last example is nicotine water system, very important. Now see, there is a case of close mutual solubility. It is close mutual solubility, very important, having critical solution temperature as well as lower temperature, that is the CST. It is CST, it is what it is? It is the critical upper solution. Okay, now upper critical solution UCT, and it is the CST, critical solution temperature. Now in this case the closed mutual solubility curve having upper as well as lower CST. Following figure shows the variations of mutual solubility with the temperature within the closed area. This is closed area. Okay, now upper solution critical temperature for nicotine water system is 208 degrees Celsius and lower becomes 60.8 degrees Celsius. Now at this stage the percentage of nicotine will be 32%. Try to understand, it is very important point in nicotine water system, that is the closed mutual solubility curve is there. Okay, now initially two phases are there and homogeneous phase will be observed at two temperatures. Okay, one is 60.8 and another one is 208. At this point the percentage of nicotine is 32%. Now this is about the partially miscibility of liquid. Now here very important, we have seen 3 points or 3 diagrams. Okay, first one is phenol water system, second one is triethyl amine water system, and last one is nicotine water system. Okay, very important. Now if any difficulty then ask me frankly. Now this is the end of our last chapter. Now see numericals based on this. Okay, we seen all the types of numerical examples. Now see one more examples related to our nth extraction. Now see the distribution coefficient of alkaloid, that is organic substance which is soluble in chloroform and water, is 20 in the favor of chloroform. Means 20 in the chloroform is organic layer and water is aqueous layer. Now K equals to C H2O upon C chloroform. Solvent means CS chloroform, CSCl3. Now this distribution coefficient is 20 in the favor of chloroform, CHCl3 in the favor of CHCl3. That's why 20 is correspond to, that's why K equals to 1 by 20 for this example. Compare the weight of alkaloid remaining in 100 ml of aqueous layer containing 1 gram of water shaken with number 1 100 ml chloroform and 2 successive 50 ml portions. Now see in this example, as you know, V is 100 ml, then V1 is also 100 ml and weight is 1 gram. Now in the first extraction, now as you know the formula x1 equals to W into Kv upon Kv plus V1, that's why W is 1 gram, then K is 1 by 20, then it is 1 by 20, V is 100 ml and first fraction of 100 ml is there, that's why V1 is there. After calculating this, you will get this x1 is equals to 0.04 gram. Now if you know V1, you know the how to calculate x2. x2 is nothing but W into Kv upon Kv plus V1, okay, raised to power 2. Now again you know the value of K 1 by 20, then here V is 100 ml, V1 is, now what happens in the successive 50 ml, now second one organic layer chloroform is taken as a 50 ml, okay, that's why here it will be 50 ml. Now in this way x2 becomes 0.008 gram. Now this is the problem based on this nth extraction. Now see number of problems are there, very important problem. See this one, concentration in aqueous layer, okay, now concentration in ether layer, okay. Now from this given data the amount unextracted will be there, calculated there, okay. Now hence the amount extracted will be this one. Why this one? Because initially this one and extracted this one, That's why there is a difference. This difference is taken there. Okay. Now this is the end of this unit. Thank you very much. Now I think our 2 units from physical in this semester is now completed. Means all the units, that is 2 units from physicals, are completed here. Now next time I will give you assignment. I think Dr. Pariyar sir will give you the assignment. Prepare that assignment, submit within the time, and be ready for our test, or we can say university example. Any difficulty, ask me freely anytime. Thank you very much.